using the sine law here to solve a triangle, and we're going to see if we can come up with more than one answer using the ambiguous case. So we're given triangle DEF with an obtuse angle this time of angle E being 144. Side E is 10.5 and side F is 12.5. So we want to find how many possible triangles could be drawn with the given measures. So let's first draw our sketch. So I'm going to draw an obtuse angle of 144, which roughly will look like this. So this will be my angle E, 144 degrees. Side E will be this one here. And F, which is going to be side F, I will draw that, let's say, over here. It's going to be 12.5. Now, on face value, this is actually impossible to do. I mean, if you look at the triangle, I mean, the obtuse angle is 144, right? So the opposite side, has to be the longest side. And this is clearly not the case because, 12.5 is given as the opposite side to angle F. And, that means, this is just impossible to make. Okay, a triangle can't have the longest side not opposite the longest angle. Okay, so right off the bat, I mean, this scenario is not possible. Okay, 10.5, this just wouldn't make sense. But you know what? Let's see if we can actually solve it or prove that using the sine law. Okay, so I'm going to set this up with sine F over 12.5 equals sine of 144 over 10.5. And if I do the math, I get sine F equals 12.5 times sine of 144 all over 10.5. So what does that give us? Well, let me just do it on my calculator to the side. Again, I'm not going to pull up my calculator on the screen. Times 144 sine equals, and I get 0.699744. Keeps going. So my angle F is going to be whatever the inverse of that is, and that's going to be 44 degrees. So right away you can tell, it's an impossibility. Okay, I mean, if I have 44 degrees over here, okay, and I try to solve this, well, 44, I mean, you see how this is just falling apart? Look at the angles, 44 and 144. I mean, that's already 188 degrees, which is greater than 180. So we don't even get an answer here, okay? So is it possible to create a triangle? Put D over here. Is it possible to create a triangle that satisfies these conditions? Well, the answer is no. This is not possible. Either triangle, okay? And just applying the sine law shows that we can't even do this.